Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC but do everything DIY. And today we have our first no cooling call for the season. Thank you to everyone tuning into Jumperman Tech. Right now this thermostat is set on auto. It says the cool is on. It's set to 68, but the room temperature is 76, and it's definitely warm in here. This is a 2-pipe fan coil unit. Oh, I just saw a drop of water just fall on me. That valve with the black handle is rusted up, and there's water coming from it. I see a little drip there that's ready to fall. Anyways, this is a 2-pipe fan coil unit. You can see the 2 pipes here. They do have heating and cooling all year round. In the summertime, we have chilled water flowing from the pipes, and that is controlled by this little motorized valve here. This is an actuator valve. So in cooling mode, this actuator valve should open and let the chilled water flow in and out. If they want heating, the chilled water valve closes. The actuator valve closes off the cold water, and an electric heater comes on. When they're in heating season, there's no more chilled water flowing through the pipes. You actually have hot water. And if they want heat, this actuator opens. So it's a bit tricky. And they're based off the temperature on the pipe, whether the electric heat or not, or the valve will open. And it's gonna be based off these 2 switches here. I call them pipe sensors, but they're auto changeover switches. I can see the bottom of this. This thing looks like it burned out, to be honest with you. Let's open up this death trap of a control panel. See what's going on. Okay, it's hot in here. First thing I want to know, is this thing pulling? Is there heat on this thing? I know it's this wire. This thick red wire. It's 2 huge wires. I know it's one of them. No amps. That's good. Why is it so hot in here? Actuator valve. There's a stem on the top, and like that, I can feel this valve is closed, so it's not letting the chilled water flow through. Here we have the 2 wires. Is it getting voltage? The handyman engineering crew here in the building told me that they just changed the actuator. To get a good view, they just changed the actuator, but it ain't working, and they basically gave up from there. Be careful here. Alright, let's check to see if we have 120 volts. And we don't. So they changed this for no reason. There's no voltage. It's just a guessing game they're playing here. Let's put this back on and further troubleshoot. At least electric heat is not going. Let's close that back up. It's gotta be these pipe sensors. Auto changeover switches. That thing looks corroded. There's a hole in the bottom. I would not be surprised. I know usually on these thermostats, it's the yellow wire. This big cable is the thermostat. So many wires coming in. This is 120. This is a line voltage thermostat. Usually the yellow wire is cooling. Let's find that yellow wire. It's this. It's this yellow wire. That yellow wire is gonna first go into one of those auto changeover switches. So it comes in red. Is that red? Okay, it's this red. And look at that. It's connected to that one that looks terrible. One wire is off. There's 3 wires there. Common, and then it has 2 paths to go to, whether the pipe is hot or cold. So then it goes to the white, and the white goes to black, and the black should energize our actuator valve. Let me see something. Where is that going? Yes, it comes here to our actuator valve. So on this one wire is not being used, but that's normal in this application for cooling. That thing's gotta be bad, but let's check it. So this yellow wire goes to this red, so this should be common for our auto changeover switch. Hopefully you guys can see. I have 120 volts from there to ground. Next, it's supposed to come out to this white and go straight into our valve. You guys saw we didn't have 120 there. Yeah. From there to ground, there's nothing. And from here to here, you're probably gonna have 120, and we do. That's a bad auto changeover switch. All right, let's turn the power off here. Let's get this thing out. I'm just gonna pop it out. Oh, that thing looks terrible, man. I'm actually in the middle of a different job in this building right now. Yeah, this thing. Ooh-wee. That thing is done. Okay, right now, I have a new auto changeover switch. We got a blue, red, and white. I got a red, brown, and black. I already know this thing is I've been messing around with these. I know red is my common on these. If the pipe is cold, red and black are gonna have continuity. If the pipe is hot, red and brown is gonna have continuity. This is the cooling actuator. So this is the cooling auto changeover switch. So as you can see, one is capped off. If it's hot, it's not gonna do anything. So the brown we're gonna cut and cap off. So we're gonna put the red common, which is gonna get connected to the wire coming from the thermostat, right? The 120 volts, the yellow wire is gonna come in and feed the red, the common. It's gonna sense the pipe is cold, and it's gonna send power, the 120, out of this black wire, and it's gonna feed our actuator valve. So let's set that up. Okay, we're gonna go with the red is that one. And then let's strip that back. Okay, that's stripped back. And then we got this white, which goes into this bunch. So right now, let me just cut that here so we know. Brown, we're gonna cut, cap off. I wanna strip these back a little bit more and have a good, solid connection. I hate making connections when everything is so short. Okay, so red, we're gonna put here, common. So wire coming from the thermostat, the 120 volts. Wire nut?
Sure.
Just one?
There you go.
Okay. The wire not being used, we gotta cap that off because when the pipe gets hot, it's gonna send power there. We don't want any problems. All right. So this white one is gonna go into this right here. Looks very rusted in there from what I'm seeing from here. Oh man, you know it's bad when you can't even get these wire nuts off. That thing is extremely rusted in there. Let's make all new connections. This thing is done. Here, Merry Christmas. All right. You know what? I'm probably gonna change both auto changeover switches. I could let. Why do one when the other one's next on its way out? I do have an extra one, so I feel like it's only right we change both. Because then we're gonna come back here for the next season, and it's just a little bit. I don't know. Just not a complete job in my opinion. So the black will come back here and energize our actuator valve. Wire nut.
There you go.
Do we have any blue wire nuts, like a little one?
We have one. I see one.
Let me get one. That's all I need.
All right. Right here. Yeah,
All right.
there you go.
Cool. I'm gonna use that to cap this off.
There's another.
We're doing this straight through, straight through. All right, Christian, let's go put that unit in cooling.
Gotcha.
Hold up a sec, the thermostat's done.
Okay.
I'm just gonna pop this off so everybody can see. Give me a second. And pop off this actuator. You don't even gotta test power if you can see it moving. So as of right now, I had it propped open. See, it's going back. It's a spring return. No power, it closes. The way you pop these off, easy. I always had trouble with it. You gotta force it open into here, press this tab and release. If not, you're gonna be in for a world of pain. Oh, you know what? Let me put this clip on. Let me put this clip on because there's gonna be problems. Whoa. It has to sense that it's cold. Let me connect this to the pipe. It's just like a little clip that goes around it and grabs on. Let's just set this up real quick so it can sense that it's cold. Either way, it should open, honestly. Even at kind of room temperature. All right, now it's on there. All right, power is on. Yeah. So you can see there's resistance here. It's closed, the spring return. Let's put it on cooling.
Got it. Cooling. Drop temperature.
All right.
All right.
Come on.
Fan currently on auto.
Okay, I got nothing here at the moment. What is there a time delay on it? It's cool on. It doesn't say cool on, right?
No.
There we go. Look at that. You can see it moving. And you're gonna see once it's actually fully open, you'll see this spring will move freely instead of having that resistance. Valve is opening. We had a bad auto changeover switch. See now? Everything's good, now it's open. I know there's 120 volts there. This is shady work right here. Shady. What is this? This is how they change it in the building? Come on, brother. Gotta do a little bit better than that. All right, Christian, turn it off. You're gonna see this spring back. That's gonna close the water. And now you see, it's resistance. It's closed. I have a connector here so we can connect this properly instead of having these wires hanging. This is dangerous and unprofessional. Unprofessional. I'm also going to change the other auto changeover switch. I'm going to keep that here for now. Turn the power off. Let's open this up. The way this opens, just gonna see that. Yeah. Let that be. Okay. We don't need all these wire nuts and wire nuts. We're good. We don't need to do all that. Let's take this off and make one connection. All those wire nuts are a potential point of failure. A lot of these guys, I even see them, they don't even use wire nuts. They literally just tape the wires together, which is ridiculous. Let's get rid of that. Let's get rid of that. This, let's just put keep the garbage like in one area. Okay. I'm gonna put one of these on. Just gonna open this up and connect it there. Let's see if we get it on there. Yes, we can. And tighten it down. Now I can run this wire through here. Get that in there. And this is the locking nut. We're gonna put it around the wire and tighten that down. It's such a tight space always. It's actually a bit tricky sometimes to do, but let's get that on there. Now this is properly connected to our actuator. I made our new connections, and let's close this up. To put this on, you want to force this open all the way to the left and drop it down, hold it down, so when it springs back, it gets stuck there. Now I should be able to just pop it on. You hear like a click. Right there. Clicked on, I can release the spring. I can hear the water stopped. Now that's done. From here, I'm gonna change the next auto changeover switch. Here's the next switch. This red is a common. It goes to the brown wire, which is heat. So let's cut that out. So red to red again. Okay, strip that back. This one went to the valve. And this red, let's see, another red. That red should energize. Let's see, yes, it goes to the coil of the relay for the electrical heater. So I'm gonna put the brown wire to that one. Uh-oh, excuse me, it's opposite. We're gonna put the black wire, so if it's cold, it's gonna turn on the electrical heater. And if it's hot, we're gonna connect that also to our, right here, our actuator, open the actuator valve. That is all wrapped up. I hate the kind of mess that it is, but these wires are not long enough to actually reach in here. So it's just a bit unfortunate, but we got two new auto changeover switches. So the way this works, let's go through the wiring real quick because this is kind of tricky. This is for cooling. Thermostat sends power 120 volts here into common, into this control. Coming out of the control, one wire, the black one, this black one feeds then it feeds the actuator valve. So that means if the pipe is cold, you want cooling, power comes in here and comes out through here, feeds the actuator. If it's hot, it goes nowhere because this is the cooling function. Next, for this auto changeover switch, which is for heating, so the wire that comes out of the thermostat for heating will energize this red wire, the comment on that control. If they have hot water, it's gonna go through the brown here and then out and feed the actuator, open up the actuator valve, send hot water. But in this strange season like we're in now, when we have chilled water, it's gonna sense that the water is cold. We cannot open up the actuator because then in heat mode, you're actually gonna start cooling off the room. So if the pipe is cold, it's going to come out through the brown wire. Excuse me, if the pipe is cold, it's gonna come out through the black wire and feed and energize our electrical heat relay and then turn on the electrical heater. And that's the way this is set. Okay, Chris, put the system on cooling.
Got it. Cooling.
All right, I'm gonna feel for that little stemp to see if it's opening. That's how I'll know it's opening. And it is, as you guys saw before. That's a beautiful thing. They're gonna have cooling now. They're complaining this room is too hot. And I don't blame them, it is. All right. So cooling is on. And we should have no amperage on this heater. As you can see, no amps, so the electrical heat is not on and the actuator is open. Let's put it on heat.
Heat. Temperature.
Okay, I can hear the actuator closed. Let's see if that relay is doing its thing. Also that second changeover switch. Oh, there we go. You see it sensed the pipe is cold. And it turned on the electrical heater. We're pulling amps now. Just make sure this is not opening. And it's not. We're good to go. And there you have it. Back up and running. This is a hotel room. Someone's actually staying in this room. They stepped out, so what a beautiful surprise. First off, that I was already in the building. And second, that when they come back, everything is nice and working. We're gonna wrap this one up here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. I'll catch you all next time.